Okay, folks, today we are going to learn how to factor trinomials. In order to do that, let's look back at what we learned last week about multiplying a binomial times a binomial. Whether you use the FOIL method or the box method, we ultimately, when we combine like terms right here, looking at this example, we end up with a trinomial. So when we go to factor a trinomial, it's kind of going to be backwards of what we're doing right here. So just a little review real quick. If we had used the FOIL method, x times x would have given us x squared, first times first. For our O, our outsides, x times 9 would have given us 9x. For our I, our insides, 1 times x would have given us 1x. And then for our last, 1 times 9 would have given us 9. Or you may have done it with the box method and you still get 4 terms. Once we get our terms, we always check to see if we have any like terms, and in this case we do, so ultimately we end up with the trinomial. What we're going to be doing now is how do we break that back apart? Factoring is a very, very important skill that we use to solve problems. The first half of this unit, which we worked on over the last week, was where we had to put it together. Now we're breaking it back apart. And when you're learning this skill, you kind of really don't understand why you're learning it, and you probably don't like it that much unless you really just like little kind of puzzles and problem solving. But I promise if you just hang in there, there's a reason why you're learning how to do this, and it's going to help us learn how to solve equations later on. All right, first step in factoring any polynomial is to always factor out the GCF if possible. Always check to see if all your terms have something in common. The next step is we're going to put our trinomial in descending order. So a basic form that we use for a trinomial is ax squared plus bx plus c, and that's that descending order. The third step is we're going to multiply the leading coefficient by the third term. This is called the AC product because technically what you're doing is you're multiplying this a right here by this constant term c right there. So that's why it's called the AC product. And then when we do that, we're going to find two factors of the AC product that add to the middle term. So before I go any further, I want to look at this. Do all three of these terms have a greatest common factor other than 1? Is there something that all three of these terms have in common? And the only number or variable that goes into all of these is 1. So we don't need to factor out 1 in the front. We know that 1 goes into anything. All right, it is already in descending order. So we're now going to step 3. We're going to multiply the leading coefficient, and even though you can't see it there, that's a 1, times the last term, which is 9. So we're going to say 1 times 9. This is the AC product. And to do this, we're going to make a little x over to the side. This is kind of, the Delta Math calls it the x gain, but it's just a little x to help us organize this information. So we're going to put our AC product up here at the top. So 1 times 9 is 9. And then you're going to put your middle term right. So pretty much what you're doing, every time you make one of these x's, you're putting the product, which is the AC product, up at the top and the sum at the bottom. So if we kind of pull this from our AC over here, it's like the AC is here and then the B is here. All right, so we put our 9 here and our 10 here. And what we want to do is we want to find the two numbers that multiply to positive 9 but add to positive 10. So if they multiply to a positive and they add to a positive, we know that both of our numbers are positive. So I'm going to go ahead and put that right here, plus, plus. So what are the numbers that multiply to 9 and add to 10? Pretty much what you're doing is you're looking at the factors of 9. So some of y'all already know the answer, and some of you may want to make a little T-chart over the side and just list your factors real quick. We have 1 and 9, and we have 3 and 3. So which of those factors would add to 10? Obviously, we can see that 1 plus 9 would be 10, so those would be our factors. So we're now gone to step 4. Now what we're going to do is we're going to rewrite the middle term as two terms using those factors. So we're going to copy down the first term just like we see it, x squared. We're going to rewrite this 10x right here using these two numbers right here and rewrite it as two terms. So we're going to say plus 1x plus 9x. And then we're going to copy our last term, plus 9. So what you can see, if you look above, we're taking this trinomial and breaking it back into the 4 terms it originally was. And once you get to this step, then we can just apply what you learned yesterday, which is the grouping method. So I'm going to draw a line right after my second term, before my third sign. And I'm going to say, okay, what do the first two terms have in common? What does x squared plus 1x have in common? Oh, it has x. So if I factor out the x, what do we have left? We have x plus 1. Remember, whatever this sign is right here, you always are going to have that sign right there. So we're going to put our plus, and then we look. What does 9x and positive 9 have in common? Oh, it has 9. So what is going to be left when we factor 9 out of these two terms? We divide both of these terms by 9. That would give us x plus 1. We check and make sure our common group is exactly the same, and it is. So we put the two GCFs in a group, x plus 9, and then we put our common group beside it, x plus 1. And the cool part about doing this is you can always check to make sure that you factored this correctly by using the box method or FOIL. In this case, I'm not going to go through that because we started out doing that so we could see what's happening there. The first part of your practice today is going to be doing these little X games where you can get that practice in. What numbers would multiply to 6 and add to -7? All right, so if they multiply to a positive number, either both of your factors have to be positive or both have to be negative. But in this case, they add to a negative number. So the only option here is both of these have to be negative. So go ahead and get your signs first. And then you have to think about it. What numbers multiply to 6, but would then add to -7? Well, our only factors of 6 are 1 and 6 and 2 and 3. So it's going to have to be 1 to 6 if it ends up combining to give us -7. So we put -1, -6, which we can check adds to -7, submit our answer, and it'll tell us we got it correct. Again, you can play videos, like if you get stuck, you can watch a little video. It'll show you how to do it. It'll show you how to break it up. But you're going to have a few of those to practice first. Okay, so let's look at another example here. So again, the first thing we want to look for is, do all of these terms have something in common other than 1? K squared, 8k, and 7. They do not. So the next step is we're going to say 1 times 7. And 1 times 7 would give us positive 7. So we are looking for the factors that multiply to positive 7, but then add to positive 8. So what two numbers multiply to 7 and add to 8? 1 and 7. So we're going to rewrite our trinomial here as k squared plus, and we're going to use these two numbers to rewrite that middle term, 1k plus 7k, because 1k plus 7k is what would add to 8k plus 7. And then once we break it down in these four terms, we can go back to the method we learned yesterday, which is grouping. So what do the first two terms have in common? K. So then we would have left k plus 1. What do the next two terms have in common? Positive 7. Remember, the sign here should always match this sign here. So what do we have left when we divide both of these by 7? K plus 1. All right, make sure your two parentheses are exactly the same. They are. So we put our two GCFs, our two outsides in a group together, k plus 7, and then we put our other group beside it, k plus 1. And then we can check it by boxing or foiling. So let's say you're a box method person. I want to make sure I did this correctly. So I'm going to come over here. We have k, 7, k, 1. K times k is k squared. K times 1 is 1k. 7 times k is 7k. 7 times 1 is 7. And then I check by combining my like terms. And if we added that together, we've got our k squared right here. 1k plus 7k would add to 8k, and then plus 7. So what we learned in the last week, you can use this week to check your factors. Let's check out the next one. So if we look at this one, do we have a greatest common factor here? And we can see that none of these terms have anything in common other than 1. So we don't need to factor anything out. So the next step is we take this first coefficient here and we multiply it by the last term. This is our AC product. So 1 times 48 would give us 48. And then we put the middle coefficient down here. That is our sum, because we're looking for what multiplies to 48 but adds to -16. So again, if it multiplies to a positive, either both of your factors are positive or both are negative. But in this case, it adds to a negative. So they would both have to be negative in this case. If you're not sure what your factors could be, make a list of factors of 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, and just start going through them until you find them. 5 does not go into 48, 6 and 8, and we've listed all our factors. So that's not going to work, that's not going to work, that's not going to work. Ooh, what about this 4 and 12 right here? If we had -4 times -12, it would multiply to +48, and it would add to -16. So I think we found our factors. So the first thing we're going to do is we're going to copy down the first term. Then we're going to rewrite this middle term as two terms using these factors right here. So we'll have -4b minus 12b, and then in the end plus 48. All right, so we're going to group them. What do the first two terms have in common? B squared minus 4b. They have a b in common. So when we factor that b out, we divide both those terms by b, we're left with b minus 4. Remember from yesterday, whatever sign you have right here, you've got to make sure you pull that out. So anytime this third term is positive, you're going to have positive right here. But anytime it's negative, you're going to have a negative right here. So you're going to have to factor the negative out with it. So what is the largest number that divides into -12b and 48? That would be -12. And you can kind of do some foreshadowing here when you're grouping. You want this group here to be the same as this one here. So you want this to also be b minus 4. So think about it. What would you divide -12b by to end up having just b right there? Obviously -12. And then 48 divided by -12 is what gives you the -4. All right, so we put our two GCFs together, b minus 12, and then we put our common group beside it, b minus 4. And then we can check it by boxing or foiling. So I'm going to come over to the side and check it by foil this time. B minus 12 times b minus 4. B times b is b squared. B times -4 is -4b. -12 times b is -12b. And -12 times -4 is +48. And then when we combine our like terms, we have b squared, -4, -12 is -16b plus 48. Okay, I would like for you to copy down number 3 and try it. And when you're done, start the video back and let's see if you did it correctly. Okay, so in this case, these also do not have a greatest common factor. The greatest number that goes into all three terms is 1. So the next step is, what two numbers multiply to -18? Because really there's a 1 in front of this. So when you say 1 times -18, the product's -18, but adds to +3. In this case, because they multiply to a negative, we know that one of our numbers has to be negative and one of our numbers has to be positive. And again, if you're struggling, list some factors of 18 to see what we're working with. So we know 18, it could have been 1 and 18. It could have been 2 and 9, or it could have been 3 and 6. We know one of them has to be negative, and when we add them, we get 3. So there's no way that's going to work with 1 and 18, or 2 and 9. But I think we can work with 3 and 6. So if it adds to a positive, we would need the 3 to be negative and the 6 to be positive, because we have more positives than negatives. And you can use your calculator or Desmos to check your signs and make sure you got the correct signs. That's probably the hardest part about all this, is making sure you have those correct signs. So right here, we copy the first term, and then we're going to have minus 3c plus 6c minus 18. A lot of times students, if they know that one of the factors is going to be negative and one's going to be positive, they'll purposely put the negative one first, then the positive, because then it makes it easier when you factor by grouping, because you then don't have to factor out that negative of the second term, two terms. So what does the first terms have in common? C. And then when we factor that c out, we divide that c out, we have c minus 3. What do the next ones have in common? Positive 6. Remember, do some foreshadowing. What do I want to divide out of here so that I'm left with c minus 3? Our two common groups are exactly the same. So we put the c plus 6 together, the outsides, and then we just put the c minus 3 beside it. Remember, you only have c minus 3 once, not twice. And again, always check by box or foil. All right, so I boxed in this one, and you can see that we have c squared, and then 6c and -3c adds to positive 3c minus 18. And when you come back, you can check that that was the original trinomial that we were given. Let's look at number 4. Remember, the first step is we always want to check and see if we have a greatest common factor. It's easy to forget to do that because not all of them have them. But if you look at this one, do y'all notice how we have 2m squared minus 2m minus 40? All of those terms have 2 in common. So the very first step is to factor out that greatest common factor. So we're going to factor out that 2 in front. And then I'm just going to put a bracket to kind of separate this. So I'm going to divide each of these terms by 2. So that's going to be 1m squared minus 1m minus 20. All right, now we're going to factor what we have left. So to get our AC product, we're going to say 1 times negative 20, not 2 times negative 40. 1 times negative 20. So I'm going to come over here and make my x, and that is going to give us negative 20. But we want it to add to negative 1. So if it multiplies to a negative, we know that one of our factors has to be negative and one has to be positive. And in this case, it adds to negative 1. So if you go through them, 1 and 20, nope. 2 and 10, nope. 3 doesn't go on to 20. 4 and 5, well, let's check it. 1. This is something you could do in your calculator. Nope, that adds to positive 1. So let's switch them. What if it was positive 4 and negative 5? Yep, that adds to negative 1. So we want to make sure that the 5 is negative and the 4 is positive. All right. One of the things that students will do is they'll forget about this 2 right here. So what I'm going to do is circle it, and I'm going to bring it down here so don't forget that that 2 needs to be floating in front. So when I'm completely done with this, that 2 should be in front of our parentheses. All right, so in the middle, we got to do our grouping. So we have 1m squared. We're going to use our 2 numbers over here, minus 5m plus 4m minus 20. And then we're going to draw our line. What does m squared minus 5m have in common? M. So then that leaves us with m minus 5. It's positive here, so I'm going to go ahead and put positive. These have 4 in common. And then that also leaves us with m minus 5. So last but not least, we're going to put the 2 outsides together, m plus 4, and then our common group beside it, m minus 5. To check this one, you would go in the exact opposite order of how we started. So I would multiply my binomials first, and then whether I use box or FOIL, and then in the end distribute the 2 back. What I have just done is teach you how to factor any trinomial. You can factor every trinomial the way that I just taught you to do it. However, something I want y'all to notice about all of these problems is they all had a leading coefficient of 1. So what I mean by that is the squared term, like look right here, k squared, c squared, right here, b squared, and then when we factored out that 2, the m squared, they all have a coefficient of 1. So when you have trinomials that have a coefficient of 1, there's actually a shortcut so that you don't have to do all this work. However, tomorrow we're going to do trinomials that have coefficients other than 1, so you will have to do this work. So if it's hard for you to remember, like, can I shortcut this one, can I not? You can always do it the way I've done the first 5 problems on this page. Here's the shortcut steps down here. If you have a trinomial with a leading coefficient of 1, so y'all see how there's not a number in front of the x squared, you would still do steps 1 from 4 above. But then you put the square root of the first term in the front of each parenthesis. So pretty much like if your variable is x, because that's x squared, you're just going to put x and x. It's kind of like you're backwards FOILing because x times x would give you x squared. And then you put the factors that you find in the back of each parenthesis. So let me show you what I mean by that. If you come back up to this first problem right here, do y'all see how we have k squared, but in the end we have k here and k here? And then the 2 factors we found that multiplied to positive 7 and added to 8 were 1 and 7. Do y'all see how those are the factors in the back? Look here, it does the same thing. We put c and c, and then look at the factors we found, negative 3 and positive 6, and that's what ends up being popped into our back of our parentheses. It happens here too, negative 4, negative 12. There they are in the back. Negative 5, positive 4. There they are in the back. So we could skip a lot of work and shortcut this, but it only works if the leading coefficient's 1. So let me show you this next one. All right. It's in descending order. It does not have a greatest common factor. So I'm going to create my 2 parentheses. In the front of each one, I'm going to put u and u because u times u is what would have given us u squared. Then I'm going to make my x. So even though you don't see the 1 there, there's still a 1 there. 1 times -4 is -4. That's our product. And then our sum, which is in the middle, is 3. What two numbers multiply to -4 but add to +3? Well, we know that if it multiplies to a negative, one of our numbers is negative and one is positive. So our factors are either going to be 1 and 4 or 2 and 2. 2 and 2 is not going to give us 3. So what if we made this -1, +4? Does that add to +3? Yes, it does. So we're going to pop those in the back. -1 plus 4. The only thing I would suggest is if you do the shortcut method, please make sure you check it. Let's make sure this works. First times first. U times U is U squared. Outer, U times 4 is +4U. Inner, -1 times U is -1U. And last, -1 times +4 is -4. Combine like terms, U squared, 4U take away 1U is 3U minus 4. Yep, and we have our original product. Pause the video and try the next one. Okay, so what two numbers would multiply to -18 but add to -7? So 1 and 18 is not going to work. 2 and 9. I think we can work with 2 and 9. We know that one's going to have to be negative and one's going to have to be positive. So if it adds to a negative, the bigger number's got to be negative. So it would be +2 and -9. All right, so we create our two sets. In the front of each set, we're going to put h and h because h times h is what gives us h squared. And then we're going to pop these in the back. -9 plus 2. And then we're going to check it. So this time I will check by boxing. H, -9, h, +2. H times h is h squared. H times 2 is 2h. -9 times h is -9h. And -9 times +2 is -18. And then we combine our like terms. H squared, -9h, and 2h is -7h minus 18. And we have our original trinomial. Our final answer, though, is the factors. All right, guys. So, again, if you do not like the shortcut method, don't use it. Just do it the long way every time. It always works. You've got a short little Delta math assignment to do now. And tomorrow we will factor all trinomials.